Okay, so with simple factorisation, what we want to do is, number one, we want to take out common factors of each term in an expression. And now what this looks like is we'll start with a simple example. Say we've got, first example, 3x minus 18. What we can see is that there's a common factor of 3 in both these terms. And what we'll do is we'll take that common factor of 3 out the front, and what remains once we've taken that common factor of 3 out is an x. So 3 times x is 3x, and when we divide 18 by 3 we're left with 6. So we'll have, once that's factorised, simple factorisation, we'll have 3 outside of x minus b. For a second example, 12x plus 30x squared. Now in this case we can take out some numerals that are going to be common factors. The highest common factor of both 12 and 30 is 6, so that's a common factor for both expressions. And one term has an x and the other term has an x squared in it, so there's a common factor of x there, so we pull that out the front. And then in brackets what remains is we have to multiply 6x by 2 so that we'll have 12x. After multiplication, there's the plus sign remains, and we need to multiply 6x by 5x so that we'll end up getting 30x squared. 6 times 5 gives us the 30, x times x gives us the x squared. So our final answer would be 6x outside of 2 plus 5x. We could do some slightly more complicated examples. In this case, we'll have 5 outside of x minus 1 minus a outside of x minus 1. All right, now in this case, the common factor is actually x minus 1, so that gives us a set of brackets here. That's the common factor. And what is left over once we take that common factor out is a 5 minus an a. So that's been factorised. Now if you remember back to when we were doing the expansion of brackets, one of the special cases that we had was a difference of two squares. All right, on the side, just a bit of a reminder, if we have a plus b times a minus b, then when we expand all of that, doing our rainbows and our smiles, we'll end up with a squared plus ab minus ab plus b squared, which eventually will simplify to give us a squared minus b squared. And I've told you that that is a really important relationship to remember. Well, if I give us an example where we start off with this kind of an expression, for instance, x squared minus 81, what we can see is that we've got a squared term here and a squared term here, because 81 is 9 squared. So if we want to factorise that, what we're going to have is two sets of brackets, and in the first set of brackets we'll have the square root of x plus the square root of 81, which is 9, and in the second set of brackets we'll have the square root of x minus the square root of 81, which is 9 again. We've now factorised a difference of two squares. Sometimes this can get more complex, and we might have something that doesn't actually look like it would be a difference of two squares, but we have to use our imagination. So let's say we had c squared minus 7. Now that 7 doesn't actually look like it's going to be a perfect square. However, if we can just remember that the square root of 7 times the square root of 7 equals 7, then that's a little bit like saying the square root of 7 squared equals 7. So we could rewrite this expression so that it's c squared minus the square root of 7 squared. And now what we have is something that looks like a difference of two squares. And if we factorise that, we'll end up with two sets of brackets, standard thing to do. We'll have the square root of c squared, which is c, plus root 7, and c minus root 7. There's some fairly simple examples of factorisation. You need to be able to apply those from your textbook.